Eric Darling here with the second in a series of videos about how the plan cache can lie to you as a plan cache looker at her. And this one is table variables. So we in the first video we looked at scalar valued functions. Now we're going to look at how table variables can make a mockery out of your entire existence. So let's hit F5 here and let's run this query here. That's going to do a couple things. Two things exactly. It's going to run two queries. Yay. Yay, two queries. You'll notice that there was a slight delay between the first query finishing and the second query finishing. If you like rewind and watch this in like super slow motion, you'll see that there was a delay. So let's. This first query is sort of unimportant to us. This is just an insert into a table variable. This is not part of our issue. The second one is this query, which selects a top 50 from the table variable and then does some other stuff. I want to point out that to get a few things. Let's start from the right and work our way forward. Up here, we have sort of a funny estimate of 128. Well, it says 1.2 million. 1, 2, 8, 6, 4, 6, 5. That's a 7-digit number. So, of course, the estimate for the table variable is 1. And the actual is 1.2, well, actually almost 1.3 million. So that's a bad start to things. However, this query doesn't end up in too bad a shape. It finishes in just about half a second, and it has a cost of 0.0331707 query buckaroos. This isn't really our problem either. Our problem is down here, a little bit further, with that query where there was a slight delay in waiting for the results. And here we're selecting a few more rows from that table variable. And we end up with a query that runs for around 5 seconds. Of course, we'll still get that same bad estimate here. All right, that same one row estimate there. However, we have the same exact plan cost as the last query. So the query that selected a top 50 has the same cost as the one that selects a top 1.2 million. This is because this all starts with the bad estimate here. A lot of times when you think about table variables, you might think, if you've been watching or listening or reading any of my nonsense, that modifying table variables is forced to run serially, but reading from them, as long as it's not from a multi-statement table valued function, is allowed to go parallel. But oftentimes that the very low estimate that you get from a table variable means that the cost of your plan gets knocked down so low that you often don't break cost threshold for parallelism in order to get a parallel plan. So this is what happened here. If SQL Server actually knew that 1.2 million rows are going to come out of this table variable, it would probably treat some of this stuff differently. It would probably not use nested loops joins and sort data over here and be goofy. It probably would just get down to business and hash some stuff up. Of course, in the plan cache, and again using SP BlitzCache, we'll have several different queries. Several different queries. But this one query in particular will warn us about low cost and high CPU again. There are some other warnings here that we don't really need to get into, but whatever. And if we look at the query plan, we'll see. Well, we'll just kind of get we'll see something that just doesn't look helpful, right? Like if you saw these two query plans side by side, they look exactly the same. They have the same costs, despite the fact that this one is only selecting a top 50 up here, and this one is selecting a top 1.2 million down here. There's the lines are all very skinny. It would be very difficult to figure out exactly why one took a lot longer than the other. And because, if we go over here and we look at how it did stuff over here, one takes about 600 milliseconds and one takes about 9.8 seconds. So I guess the point is, if you take that top 51 out of the equation, like pretend you didn't see it, and you just saw this thing, and the query plan looked, all tiny and dainty, and like there was really nothing going on in it, you might stare at this thing and be like, well, I don't know. Why are the lines so skinny? Why did something with such skinny lines take so long? I don't know. It can be very, very confusing sometimes. Anyway, that is how table variables can get into the plan cache and lie to you about things, and that is why in BlitzCache I wrote a check for table variables. Right, so we see table variables, table variables, table variables everywhere. Interesting stuff. Because they can lie to you, and you can get those bad estimates. Now, SQL Server 2019, in stored procedures, table variables got a little love, where on the first they act kind of like parameters, where like on the first execution you'll get like the deferred compilation cardinality estimate, meaning you'll get like the table cardinality. You still don't have like column level statistical distributions of what's in your table variables, but you at least get like the full table cardinality. The thing is that value is sniffed and reused. So in this case, it might have helped since we put the same number of rows in both times. But if you have table variables that get populated by different ways and end up with different number of rows from execution to execution, you could just end up with like sort of like a weird parameter sniffing issue, like with table variables now. Like now, like everything with an @ sign in front of it is your enemy, right? To this day, if it starts with an @ sign, it's your enemy. Like all of Twitter, variables, parameters, table variables, all sucks. Twitter handles. Everyone on Twitter should be, I don't know, hugged, hugged really hard. Maybe it will stop bringing out the worst in people then. Anyway, I am Eric Darling with Eric Darling Data, and in the next video we will talk about, if you're again, the wandering eyes may have betrayed you. We'll talk about how row goals can make query plans look a little bit strange too. So that will be the next video. Hold tight. See you there.